Okay, in part A, we were talking about coterminal angles. So remember that each angle has an initial side which rotates and then it ends, right? And where something ends, we say it terminates, so that's the terminal side. So if two angles end at the same place, they have the same end or the same termination, we call them coterminal. Right, so these two angles end at the same place, even though we get there in different ways. So we could just rotate 50 degrees, or we could rotate 360 and then an additional 50 degrees, right, and get to 410. So how else can we get to the same place of 50 degrees? Well, we can also go this way in the negative direction. Now, if we've gone in the negative direction, that's like doing 50 degrees minus 360, right? Going in the opposite direction. And that would get me negative 310 degrees. Now, I can also get here by, instead of rotating around one time and then adding 50, of course I can rotate around twice and then add 50. So this is sort of an infinite process because we can spin around as many times as we want, either in a positive or a negative direction, and as long as we add this little bit right here, right, which is that 50 degrees, then we should end up at this same place. We should have this same exact end or be coterminal. So the idea is that you can take any angle and you can either add or subtract 360 degrees. Now if k is a positive number, then we'd be adding 360. And if k was a negative number, we'd be subtracting 360. And we can change k so that we have multiple values of 360, so we could spin twice or 10 times or 100 times if you wish. So let's take a look at using the definition of coterminal angles to find some. So write an equation to represent all angles coterminal with 30 degrees. Right. So here's the initial side and here's the terminal side. And this is my 30-degree angle right here. So how many different ways can I get to 30 degrees? Well, I can do 30 degrees and spin around one full time first. So that would give me 390. I could have 30 degrees, or I could spin around twice. And that would give me 750. And I could have 30 degrees, and I could spin around 10 times. So in general, to write an equation which represents all of the angles that are coterminal with 30, it would be 30 plus some multiple of 30 degrees. In this case, it's important to note that k is an integer, meaning that it has to be a whole number since we need whole rotations of 30 degrees. For the second problem, find two positive and two negative angles that are coterminal with 30. So if we want positive angles, well, that's not that hard to do. So positive angles are just going to be 3 30 degrees plus multiples of 360. So I could do one multiple of 360 or two multiples of 360. As long as the numbers are positive, I know it's going to be a positive number. If, on the other hand, I want negative angles coterminal with 30, all I have to do is add negative multiples of 360. So 30 degrees plus negative 360, which is going to be negative 330. And of course, if I want, I can do 30 degrees plus, now this would be two counterclockwise, two clockwise rotations around. And I'm just spinning around twice, but going in the negative direction. And that would give me negative 720 plus 30, which would give me negative 690. Okay. So we can see that if I want a negative angle, I add over here, right? These are negative values, negative multiples of 360. And if I want a positive number that's coterminal, I can add different positive multiples of 360. Okay, so on your worksheet, looking at numbers 11, 12, and 13, take a minute to pause the video here for 5 to 10 minutes so that you can answer problems 11, 12, and 13. Then check in with somebody, do a pair share, ask good questions, and when you're ready to resume the video, you can. Okay, the next thing we want to look at in this section is something called a reference angle. So reference angles can seem kind of tricky because it looks like there's a lot of rules here. For any angle alpha, and this just says alpha is between 0 and 360. In other words, it's an angle I can make in a circle, in a unit circle. And we define its reference angle in several ways. And it looks like there's a lot of rules here, but really it's actually very easy to find a reference angle. So in the first quadrant, the reference angle is just itself. Okay. The angle is just equal to itself. In the second quadrant, the reference angle should be a mirror image, right? These should be mirror images, okay? In the third quadrant, these are going to be vertical angles. Okay, you see that? So this is a reflection. Let's see. Reflect over the y-axis. In the third quadrant, it's going to be a vertical angle. Okay, recall from geometry that vertical angles are congruent to each other. And in the fourth quadrant, okay, if this is my angle, alpha, then its reference angle is just the same angle, but now flipped over the x-axis. So this is a reflection over the x-axis. It might seem sort of a strange thing. Why do we have these reference angles? What is a reference angle? What does it reference to? But really, when we start drawing triangles in the coordinate plane and using those triangles to find trigonometric values, the reference angles become very important. So it's nice to sort of have a nod to it right now while we're just talking about angles. So let's look at the basic idea for reference angles. So here's a 30-degree angle in the coordinate plane. Okay, this is a 30-degree angle. Now I know that in a 30-degree angle, and this is a right triangle, that makes this a 60-degree angle. And if I remember anything from geometry, I might remember that if this is, let's say, x, then this is 2x, and then this side is x root 3. So essentially I can create this triangle 4 different times. Right? Once in the first quadrant, once in the second quadrant, once in the third quadrant, and once in the fourth quadrant. And the triangle is always the same. In other words, this is always 2x and this is always x. Right? This is 2x. This is x. Oops, that's supposed to be an x. This side's x root 3, x, and 2x. So that makes this a 30-degree angle, and that makes this a 30-degree angle, and that makes this a 30-degree angle. Essentially what happens when you create this triangle 4 times is that means that different angles have the same triangle. Okay, so this is a 30-degree angle over here, but it has the same triangle as a negative 30-degree angle, right? If we come down this way. Now, this is a 30-degree angle here, but if I rotate all the way around over here, such that I'm 30 degrees shy of 180, then this angle right here is 150 degrees. And so it turns out that a 30-degree triangle will have the same sides and measures and angles as a triangle that we made with a 150-degree angle. Okay. And I can make the same sort of arc all the way over here, And this time, instead of stopping at 150, I can go 30 degrees past. And now this is 180 plus 30 more. That's 210 degrees. So now we see that a triangle made with a 210 degree angle essentially has the same parts and angles as a triangle with 30 degrees. So the reference angle is 30 degrees because all those triangles are made with a 30 degree angle relative to the origin. But the way that we get to the terminal side is by measuring, of course, from the start. Over here, right? This is the initial side. So this becomes really important as we start working with trigonometry a little more. But for now, we can just say what is a reference angle. And what you'll notice that when we make these four triangles is that they sort of form like this little bow tie. So I always say, well, what's the bow tie angle? And if you're not sure what a reference angle should look like, you draw a little bow tie, and then you can quickly find the reference angle. So for instance, find the measure of the reference angle. So, oops, I already have a picture here. Okay, so let's draw 120 degrees. So 0, 30, 60, 90. All right, 120. Here's the angle. This is 120 degrees. So remember that we're going to make a little bow tie. Now the question is, what's this angle right here? Because whatever this angle is right here, it's the same angle here, here, and here, which means this 120 degree angle has the same parts as all these other triangles. So if this is 120 and all the way halfway around the circle is 180, that makes this guy 60. And so his reference angle is 60 degrees. Let's look at B. Negative 135. So this time, of course, we're going to go clockwise. Negative 30, negative 60, negative 90. And negative 135 lives right over here. Okay. So let's make our bow tie. It's sort of a sloppy bow tie. But whatever this angle is, right here is my reference angle. And it's the same angle as here, and here, and here. So if this is negative 135, how much more until I get over to the x-axis? What's this angle right here? Well, of course, it's a 45 degree angle. And so the reference angle here is 45 degrees. Okay, so now looking at your same worksheet, I'd like you to take a look at problems 11 and 12. And I'm thinking that these are on the same side of the worksheet we've been working on, but they may be on the back. So you may want to flip your worksheet over and take a look at problems number 11 and 12 on the side that says 5.1. Or maybe they're at the bottom. I can't remember. Anyways, take a look at the problems 11, find the measure of the reference angle for 227, and find the measure of the reference angle for 640. Remember that for 640, you're going to have to go around the circle at least one full circle, one full rotation first, before you can draw 640 and then find the reference angle. So go ahead and pause the video now if you need to. Okay, so hopefully you remember how to find the sine, cosine, and tangent for triangles. The sine, of course, is the opposite side to the hypotenuse, that ratio. Cosine is adjacent side to hypotenuse, and tangent is opposite side to adjacent. Sometimes you hear SOHCAHTOA to help you remember the ratios. You guys are going to be practicing some problems with SOHCAHTOA on your worksheet tonight, just as a reminder, and it's just some basic trigonometry. So hopefully have your calculators and be practicing some of these, and when we get together on Friday, we'll go over them together.